All right, in this video, we're going to talk about a review or supplement to section 2B, dealing with extending unit analysis. We're going to talk about powers of 10. The powers of 10 indicate how many times to multiply 10 by itself. Like 10 to the second power, that means 10 times 10. That's 100. The exponent tells us how many times we take that base and multiply it by itself. Also 10 to the 6th. Yeah, 10 to the 6th. That's 10 times 10 times 10 times 10 times 10 times 10, or 1 million. And also negative powers are reciprocals of positive powers, like 10 to the negative 2. The way we can write that is this. We can write this with a 1 on top and then pull the 10 in the denominator, make the negative 2 positive 2, so it'll be 1 over 10 squared. And then 10 squared is 10 times 10, which is 100. We can write that as 1 over 100, or as a decimal, 0.01. Also, 10 to the negative 6 can be written like this, 1 over 10 to the 6. 10 to the 6 can be expanded as 1 million, so you got 1 over 1 million, and as a decimal will be 0.000001. Now note that the powers of 10 follow 2 basic rules, like this one. Number 1, a positive exponent tells how many zeros follow the 1. Like in this case here, 10 to the 0 is 1, followed by no zeros. 10 to the 8th is a 1, followed by 8 zeros. And then number 2, a negative exponent tells how many places are to the right of the decimal point, including the 1. Like, for example, 10 to the negative 1 will be 0.1. It only has 1 place to the right of the decimal point. 10 to the negative 6 has 6 places to the right of the decimal point. So we write that as 0.000001. Okay. Let's talk about multiplying and dividing powers of 10. The examples that you see here show that we can multiply powers of 10 by just simply adding the exponents. And not just powers of 10, we can multiply powers of the same base by adding the exponents. Well, we're just dealing with powers of 10, like 10 to the 4th times 10 to the 7th. Well, 10 to the 4th is 10,000. 10 to the 7th is 10 million. So 10,000 times 10 million would be 100 billion, which is, in this case, if you were to write that in exponential form, 10 to the 11th power, because that's 10 to the 4th times 10 to the 7th. It'll give you 10 to the 11th. So we just simply add the exponents of 4 and 7. Also, 10 to the 5th times 10 to the negative 3. Well, 10 to the 5th is going to be 100,000. 10 to the negative 3 will be 0.001. So if you add the exponents of 5 and negative 3, you'll get 10 to the 2nd, which is equivalent to 100. And here's one with both powers of 10 being negative exponents. 10 to the negative 8 times 10 to the negative 5th. Okay. We write this out as 10 to the negative 8, and this is going to be 10 to the negative 5th to get all of this. Okay. And it's going to have 13 digits after the decimal point. So 10 to the negative 8 times 10 to the negative 5th, we add negative 8 plus negative 5 to get negative 13. So it ends up being 10 to the negative 13. So you got to keep in mind, this only works if you're multiplying powers of the same base. And in this case, you're multiplying powers of 10. Now, what if you were dividing powers of 10? Or dividing powers of the same base? To be exact, you subtract your exponents. Like 10 to the 3rd, 10 to the 5th divided by 10 to the 3rd. Well, 10 to the fifth is 100,000 divided by 10 to the third, that's 1,000. Take 100,000, divide that by 1,000, you'll end up with 100, or simply 10 to the second. Just subtract 10 to the 5 minus 3. Let's see, the other examples are right here. 10 to the third divided by 10 to the seventh. We can still subtract exponent. 10 to the 10 to the third, that's 1,000, and 10 to the seventh, that's going to be 10 million. Divide 1,000 by 10 million, you'll get 0.0001, or 10 to the negative fourth power. Simply put, bring the 10 over, subtract 3 minus 7, you'll get -4. Also, with 10 to the -4 divided by 10 to the -6. Expand this out, you'll get 100. Or bring the base of 10 over, subtract -4 minus a -6, which is the same as -4 plus 6, which is 2. So it'd be 10 squared. Okay. Now, powers of 10. That's another way of saying raising a power to a power. We can use the multiplication and division rules to raise powers of 10 to other powers, like in this case, 10 to the fourth raised to the third power. That exponent of 3 on the outside means that 10 to the fourth will be used as a factor 3 times. So I can write that as 10 to the fourth times 10 to the fourth times 10 to the fourth. And here we're multiplying powers of the same base, which is base 10. So we add the exponents of 4 plus 4 plus 4. We'll end up with 10 to the 12th. The same result can be obtained by just multiplying the two powers together. Just multiply your exponents. 10 to the fourth raised to the third would be 10 to the 4 times 3, or 10 to the 12th. Okay. Now, there is no shortcut for adding or subtracting powers of 10. Those values must be written in longhand notation. Like, for example, 10 to the 6 plus 10 squared. Well, 10 to the 6 is going to be 1 million. 10 squared is 100. So 1 million plus 100 will be 1,100,000. Also, 10 to the 8 times plus 10 to the negative third. Just have to write 10 to the 8th as 100 million. 10 to the negative third is 0.001, and add the two together to get 100,000,000.001. And also 10 to the 7th minus 10 to the third. 10 to the 7th will be 10 million. 10 to the third is 1,000. Subtract 1,000 from 10 million, you'll get 9,999,000. Okay, so you just have to expand those exponents of powers of 10 out completely in order to add and subtract. So to summarize what I just said here, to multiply powers of 10, you add the exponents. 10 to the n times 10 to the m, we just bring over the base of 10, add the exponents n and m. Dividing powers of 10, you subtract your exponents. 10 to the n divided by 10 to the m, bring the base over of 10, subtract your exponents, n minus m. And then to raise powers of 10, raise powers of 10 to other powers, you just multiply your exponents. In this case here, 10 to the n raised to the m, bring the base over of 10, and then multiply n and m together. Okay, so we're going to be using these rules with these examples here that's on the next page that I have here. Like in part A of example 1, we got 10 to the 5th times 10 to the 7th. Notice we're multiplying both powers of 10. So we bring the base over of 10 and then just add 5 and 7 together. So here 5 plus 7 would be 12. So 10 to the 5th times 10 to the 7th would just simply be 10 to the 12th. Okay. Part B, 10 to the 4th times 10 to the negative 2. Again, we're multiplying powers of the same base, so we bring the 10 over, add 4 and negative 2. And of course, when you're adding integers with different signs, you subtract and take the sign of the larger. We subtract 2 from 4, which is going to be 2. The larger of the 2 is positive, so that exponent of 2 will have to be positive. So 10 to the 4th times 10 to the negative 2 would be equal to 10 squared, or 10 to the 2nd. C and D are division problems. Those are the ones you're going to have to subtract your exponents. 10 to the 12th divided by 10 to the 4th. This time we're dividing powers of 10. So we bring that base of 10 over, subtract 12 minus 4. 12 minus 4 will give you 8. So 10 to the 12th divided by 10 to the 4th will be 10 to the 8th power. Part D, 10 to the 9th divided by 10 to the negative 3rd power. Bring the base over of 10, since we're dividing powers of the same base. We're going to subtract 9 minus 3, the top minus the bottom exponent. 9 minus a negative 3 is the same as saying 9 plus 3. When you subtract, you add the opposite. So it'll be 10 to the 12th power. Okay, number 2. We're going to evaluate the following expressions, like in part A. 10 to the 21st divided by 10 to the 15th. Notice we're dividing powers of the same base. So we bring the base of 10 over. This time we subtract the exponent in the numerator minus the exponent in the denominator. So 21 minus 15 will be 6, so it'll be 10 to the 6th power as the final answer. All right, part B. This time we got 10 to the 0 power plus 10 to the 1. All right, now 10 to the 0, and you do have to understand for the fact that 10 to the 0 is 1, followed by no zeros. So 10 to the 0 is just going to be 1. 10 to the 1 will be a 1 followed by only 1 0, because the exponent there is 1. So now you got 1 plus 10, which will give you 11. All right, part C is an addition problem as well. 10 to the 4th plus 10 to the negative 1. Well, 10 to the 4th will be a 1. That exponent of 4 means I need 4 zeros behind the 1. So it'll be 10,000 plus 10 to the negative 1 means I'm going to have one number after the decimal point. So it'll be 0 point, and it'll be a 1. Because I can only have one number after the decimal point. So 10,000 plus 0.1, my answer would be 10,000.1. And finally, part D, 10 to the 4th minus 10 to the 1. Well, 10 to the 4th is a 1 with 4 zeros behind it. So that's 10,000 minus 10 to the 1 is going to be a 1 with only 1 0 behind it. It's 10. Subtract 10 from 10,000, you'll end up with 9,990. Okay. So that does conclude this short section or short review on powers of 10.